Good day, students. You should be in your Math Nation course workbook or your Math Nation packet on page 59, number 1 for the Let's Practice. So let's look at this problem. It says to complete the chart using the following information below. So we're looking at a two-column proof, and anytime that we have a two-column proof, we are given statements and reasons. So the statements are posed about what you see in the figure, and the reasons we can always answer using definitions, theorems, or postulates. So something that we already know to be true. All right, so let's look at what's been given to us. So the first thing that has been given to us is that angles 4 and 7 are supplementary. Okay, so we know that there's a relationship to that. And if it's given, then that can just be put here in this first statement. So remember, when we're doing a two-column proof, normally the first couple statements are always given to us anyway. So we got that first statement out the way. Second statement says that angles 8 and 16 are congruent. So I know that these two angles right here in the picture are congruent. We can go ahead and label that there. And we can also fill that in for our second statement, since the reason is already given there as well. So let's move on to number 3. So statement number 3 says we have two pairs of angles that are congruent. We have angle 7 and angle 6 to be congruent, and we have angle 13 and angle 16 to be congruent to each other. So remember, we're trying to find a reason of why these angles are congruent. And remember, the reason can either be a definition, a theorem, or a postulate. So if I look at the position of angle 7 and angle 6, and angle 13 and angle 16, I notice that these angles are opposite from each other, and they also share a common vertex. So if we remember back from lesson 1, opposite angles are called vertical angles. So we know that these two pairs of angles have to be vertical angles, especially if they're congruent, because we also know congruent angles have the same measure. I'm sorry, vertical angles have the same measure. All right, so number 4. So number 4, the reason that's been given to us is the substitution property. So that just means the statement that we're looking for is something that's being substituted between the previous statements that were given. So let's look at the first statement, statement number 1. 4 and 7 are supplementary. So I have to look at the statements that come after statement 1 to see if there's anything that I can replace for either angles 4 or 7, or if 4 and 7 have already been repeated. So I noticed that angle 7 was also mentioned in statement 3. And statement 3 says 7 and 6, angles 7 and 6 are congruent to each other. So if 7 and 6 are congruent to each other, that means that they're the same angle. So if they're the same angle, that means I can replace, and remember that word substitution just means to replace. That means I can replace the measure, angle 7 with angle 6 for the statement in number 1. So instead of saying angle 4 and angle 7 are supplementary, I can say angle 4 and angle 6 are supplementary because 7 and 6 are the same angle. And then we have to look again to see if there's another angle that was mentioned in the previous statements that was also repeated. So if I look at statement number 2, I notice that angle 16 was mentioned again in statement 3. So statement 2 and statement 3 mentions angle 16. Well, statement 2 says angle 8 and 16 are congruent, and statement 3 says angle 13 and angle 16 are congruent. So if we look at these two statements, I can replace angle 16 for angle 13 and say instead of angle 8 being congruent to angle 16, I can say 8 and 13 are congruent. So all I did was replace what I saw in the previous statements for the angles that I saw that were repeated. So now we're getting down to what we need to prove, and that's statements 5 and 6. So statement 5 says we're trying to prove that lines L1 and L2 are parallel. So anytime that you're trying to prove lines are parallel, you're always going to use some type of converse theorem. So remember, we talked about using the converse. That's just replacing the order of the original statement. So that means if the replacing of the original statement is true of the order, then that means that we can prove it to be true as well. It's a true statement. So I'm looking for a relationship between angles that sit on line L1 and line L2 that hold true. So first, let's identify lines 1 and 2. So we have L1 and L2 here. And what two angles sit on lines L1 and L2? Well, just look at the previous statements that were made. If I look at angle 4 and 6, I notice that angle 4 and angle 6 sit on L1 and L2. And we already know that 4 and 6 are supplementary, right? And if they're supplementary, that means they have some type of angle relationship. So if we look at the previous angle relationships that we just discussed on pages, pages 57 and 58, we notice that these two angles sit in between the parallel lines, and they are on the same side of the transversal. So the transversal here would be line T1. So 4 and 6 are on the same side of the transversal in between the two parallel lines. So that tells me that to prove these two lines are parallel, I would say that this is the converse of same side interior angles. And remember, another word for same side is consecutive. Okay. Now let's look at number 6. So number 6 now says we have to prove that line T1 and line T2 are parallel. So again, we're looking at now T1 and T2, which are in green, and we're looking for two angles that sit on T1 and T2 that has some type of angle relationship that we looked at on pages 57 and 58. So the only one that's left is 8 and 13. So when I look at angle 8, let's do another color, angle 8 and angle 13, I notice that angle 8 and 13 are on opposite sides of the transversal. So remember that transversal is here. I'm going to put it in orange. So the transversal line is L2, and it's sitting on opposite sides of the transversal in between the two green lines, which are T1 and T2. So if we go back to what we learned about angle relationships on page 57, we notice that these two types of angles are considered the converse of alternate interior angles. So we have now proven that lines L1 and L2 are parallel to each other, and lines T1 and T2 are parallel to each other by the converse of same side interior angles and alternate interior angles.